What is going on here? So, Julian, you started for a technical interview? Yeah, I am, but I'm really nervous. Man, I can't revert a binary tree, reverse a linked list. Wait, when is your interview? I'm thinking it's in about 5 to 10 minutes. You probably want to fail, but if you ever get stuck during your interview, just throw a HashMap at the problem. Bro, a HashMap? Bro, what? It's time. Hey Julian, I'm Julian with an E. I am a senior software engineer at Met Google AppFlix. I'm just going to send over a code doc to you and we could go ahead and get started with our technical interview today. Yep, sounds good. Are you ready for the prompt, Julian? The prompt is given an array of integers, nums, and an integer target. Return indices of the two numbers such as they add up to the target. And you can assume that there always will be a solution. Some will be better than others. Let me know when you're ready to get started. What an easy problem. I did this LeetCode problem last night. Which coding language should I choose, Java or Python? Interesting. I think my initial approach will use 2 for loops and iterate through the array, checking after whether the sum of the current number and each of the numbers in front add up to the target. Yep, sounds like a great approach. Do you want to get started and code it up? Yeah, sure, no problem. I could start coding up right now. And in the event there's no solutions, we will throw an error. That should work, and the time complexity is O(n) squared because for each element we are looping through the rest of the array to find its complement, which takes O(n) time, which the space complexity would be O(1). It is a bit slow as you mention your time complexity. Do you think you could write a faster algorithm for me today? Of course, I knew this would happen. Yeah, we could sort the array first and use a left and right pointer and move those to the middle of the array, depending on if the sum is less than or greater than our target. And so the time complexity of this solution is O(n) log n, because we would have to sort the array and we also have one pass through the array, which is O(n). Similar to the previous version, our space complexity is still O(1). Yes, I did it. I'm finally about to make it into the Magnificent 7. Yes, this is a bit better, but it's still a little slow on the time complexity error. I want you to think of solution in linear time. Can you do that for me? What? Linear time? I thought I already got the optimal solution. There is no way you can make this any faster. Yeah, I guess we can, and we can add the, and add it up to the, target, Hey Julian, we have about 5 minutes left. If you can't think of a better solution, don't worry about it. Come on, Julian. Think. What can I do? I am so stuck right now. Wait, stuck? But if you ever get stuck during your interview, just throw a HashMap at the problem. Just throw a HashMap. Yeah, so we can use a HashMap. I will iterate through the array and find the complement of each number, and if the complement already exists in the HashMap, then we can just return the corresponding value, which is going to be an index along with the current index and the sum of numbers at those two indices will add up to our target. And if the complement doesn't already exist in the HashMap, then we will add it to the HashMap and we'll store our current number and current index into our HashMap. Yep, that sounds like a pretty good plan. We have a few minutes left, so if you could code up your solution real quick, that would be perfect. Yep, I could start coding that up right now. As I mentioned before, if there is any event where the index is not stored in a hash map, then we will be storing the index in a hash map so we can find their indices. And in terms of time complexity, since we're looping through the array once, and since the hash map has constant lookup times, the time complexity is O of n, and our hash map would store at most, so the space complexity would be O of n2. Perfect. Well done, Julian. That concludes our interview for today. Be on the lookout so you can schedule your next interview and the more following technical interviews, more to come. See you soon. Thank you. You too. Wait, did he say another interview?